Imagine a world where particles can be in two places at once, where observing something can actually change it, where things only happen when you look at them, and where the rules that govern our reality seem to break down entirely. Welcome to the world of quantum physics. For most people, quantum physics sounds like rocket science. Confusing, complicated, and best left to scientists in white lab coats. But today we're going to change that. We're going to take the mystery out of quantum mechanics and explain it in simple human language. No fancy math, no PhD needed, just pure understanding. Because quantum physics isn't just about science, it's about how the universe truly works at its deepest level, from the tiniest atoms to the most mind-bending theories of reality. So whether you're a curious student, a science lover, or just someone who wants to understand the truth behind reality, stick with me. This isn't just a science class. This is a journey into the strange, bizarre, and beautiful world that lies beyond what we can see. Let's begin. So, what exactly is quantum physics? Let's break it down. At its core, quantum physics is the science of the very, very small. We're talking about particles so tiny they make atoms look huge. Electrons, photons, quarks, the building blocks of everything in the universe. Now you might think, okay, but don't we already understand how things move and work? Like gravity and motion and all that. And yes, that's true. We've got classical physics, which is the stuff Isaac Newton figured out centuries ago. Like when an apple falls from a tree, or how a car moves when you hit the gas. But here's the thing, when scientists started looking deeper, really zooming into the tiniest parts of matter, they realized that Newton's rules don't apply anymore. It's like reality itself. Glitches. Particles behave like waves. Waves behave like particles. Sometimes they act like they're in more than one place at the same time. Welcome to the quantum world. It's weird, it's wild, and it's real. Quantum physics helps us understand how light works, why atoms are stable, how the sun burns, and even how electronics like smartphones and computers operate. Without quantum physics, there would be no modern technology, no lasers, no GPS, no internet, no transistors. Crazy, right? And here's the best part. Even though quantum mechanics was discovered over 100 years ago, we're still trying to wrap our heads around it today. In the next part, we'll dive into one of the strangest concepts ever discovered: wave-particle duality. How something can be a particle and a wave at the same time. Sounds impossible? Not in the quantum world. Stick around. Alright, now it's time to talk about one of the weirdest things in quantum physics: wave-particle duality. So here's the deal. In everyday life, everything around us is either a particle or a wave. A baseball, that's a particle. Ocean waves? Clearly waves. But in the quantum world, things get strange. Let's take light, for example. For a long time, scientists thought light was a wave, like ripples in a pond. Then, we discovered it also behaves like tiny particles called photons. Wait, how can something be a wave and a particle? That's the puzzle. That's wave-particle duality, but it gets crazier. This same duality applies not just to light, but to matter too. Yes, even you are made of atoms that have wave-like behavior at the tiniest level. One of the most famous experiments that shows this is the double-slit experiment. Here's how it works. Imagine you shoot tiny particles, like electrons, at a wall with two slits in it. Behind that wall, there's a screen that shows where the particles land. Now, if electrons were just particles, you'd expect to see two stripes where they went through the slits, but surprise! You get a weird interference pattern, like ripples from waves crashing into each other. It's as if the electrons went through both slits at the same time, interfered with themselves, and only decided where to land once we measured them. Mind blown, right? Even crazier, if you try to watch which slit the electron goes through, it stops acting like a wave and goes back to being a particle. In other words, just observing it changes its behavior. This isn't just science fiction. It has been repeated over and over in real experiments. It means particles aren't really solid little balls. They're more like probabilities or clouds of possibilities until we look at them. And that leads us straight into the next mind. Alright, hold on tight, because what we're about to explore now might change how you think about reality itself. It's called the observer effect. Here's the strange part. In the quantum world, just watching something changes it. Remember the double slit experiment we just talked about? When no one observes the electrons, they behave like waves, going through both slits at once, creating an interference pattern. But the moment we try to observe them, boom, the wave collapses and they act like particles again. It's like the particle says, wait, someone's watching me, okay, I'll behave. But why? How can just observing something make it change? Some scientists say it's because of measurement, that the act of measuring disturbs the system. Others believe it reveals something deeper, that maybe the universe itself is incomplete without a conscious observer. Yes, you heard that right. Some interpretations of quantum mechanics suggest that consciousness affects reality. Of course, this is still a big debate in physics. Not all scientists agree. But one thing is certain, the quantum world doesn't behave until we look at it. Before we observe a particle, it doesn't have a fixed position. It exists in a superposition, meaning it's in many states at once. It's only when we measure it that it chooses a state. It's like flipping a coin and it being both heads and tails in midair. Until you catch it and look. Then, and only then, it decides what it is. Wild, right? So now the big question. If reality is shaped when we observe it, then what is real? What's happening when no one is watching? That's where things get even deeper, with concepts like quantum entanglement and non-locality. But don't worry, I've got you. In the next part, we'll explore how particles can be connected across space and time. Alright, now we're entering the spookiest part of quantum physics. It's called quantum entanglement, and trust me, it sounds like science fiction, but it's very real. So what is it? Imagine you have two tiny particles, let's say electrons. Now you do something special to them so that they become entangled. This means from that moment on, no matter how far apart they are, across a room, across a country, or even across the entire galaxy, these two particles stay mysteriously connected. If you measure one particle and find it spinning up, the other one will instantly be spinning down. It's like they know what the other is doing in real time. But here's the insane part. That instant connection happens faster than the speed of light. Yes, faster than light, which goes against everything we know in classical physics. Even Einstein couldn't believe it. He called it spooky action at a distance. And to be fair, he wasn't wrong to be skeptical. It sounded too weird. Too magical. But experiment after experiment has proven this effect to be real. So what does this mean? Does information travel instantly through some hidden channel? Are particles secretly communicating? Or, and this is the big one, is space itself an illusion and everything is somehow connected beneath the surface? That's the kind of question quantum physics forces us to ask. Some scientists think entanglement might hold the key to a unified theory of everything. Others believe it could help build a future of technology, like quantum computers or teleportation. Yup, we're not making this up. In fact, entanglement is already being used in quantum encryption, which might someday make hacking impossible. But let's not get ahead of ourselves, because the more we learn, the more we realize how little we understand about the universe. And that brings us to the final part of this journey. What does all of this mean for us? So far, we've seen how the quantum world bends the rules of reality. Particles being in two places at once, the universe reacting just because we looked at it, and spooky connections across space. But now the big question is, why does it matter? Well, here's the truth. Quantum physics isn't just some abstract theory cooked up in a lab. It's already changing your life whether you realize it or not. Let me explain. Your smartphone, your computer, GPS, the internet, all these technologies are built using quantum principles. Take transistors, the tiny switches inside your phone. They work because of quantum tunneling, where particles pass through barriers they shouldn't be able to. Or GPS satellites. They use relativity and quantum timing to measure your location precisely. If we ignored quantum effects, your Google Maps would be off by kilometers, and this is just the beginning. Right now, scientists and engineers are working on quantum computers, machines that process information using qubits, not bits. They can solve problems in seconds that would take normal computers centuries. Quantum cryptography, a way to make data unhackable using entangled particles. Quantum teleportation, yep, is real at a particle level, and it could change how we send data forever. Quantum sensors, for detecting diseases, earthquakes, or even gravitational waves with mind-blowing precision. So next time you think quantum physics is just for scientists, Think again. It's the future of medicine, security, space travel, AI, even our understanding of consciousness. But most importantly, quantum physics teaches us one very human lesson: that the universe is far more mysterious, interconnected, and magical than we ever imagined. It humbles us, it excites us, and it reminds us that even the smallest particles can hold infinite possibilities. So whether you're a student, a dreamer, or just someone curious about the world, welcome to the quantum revolution. It's not just physics, it's the future. Thanks for watching. If you found this video fascinating, don't forget to like, share, and subscribe for more deep dives into the mysteries of science. Let's keep exploring together.